All right, let's move on. All right, welcome back. We are Game 2014. That's Mobile Game Development 1 at George Brown College in the fall 2021 semester, and it's week 9, part 2 of our broadcast. The first one, we talked about a little bit about platforming mechanics. We also described the details for assignment 2, part 1 and part 2. And we talked about our platformer primer, which was, I asked you guys to select 2 of these from these 2 pages, page 39 and 40 of the week 9 notes, right, which we'll be getting back into. And I'll be trying to help with a couple of these as we move towards the end of the semester. But for now, what we also did is we set up a base project that we were working with in Unity, right? So we have a lab 6 that I've kind of created for you guys, and this we're going to continue from where we left off. So the first thing we need is some kind of platform that the player can sit on top of. Let's do that first. Again, what I want to do is I want to go to the platform layer and talk about the platform layer. Why I called it the platform layer and not something else, not just tile map. This is where the platforms are going to appear, and there might be a background layer. There can also be a depth plane layer. There could be other layers. But for now, I want to make it so that there is a platform layer on order and layer 1, which means that there could be something behind that. Order and layer describes the layering, how things stack. And I want this to be the second kind of level of the stack that I'm going to create for us in 2D. So platform layer is order and layer 1. The next part is I wanted to add in my platform. So let's take a look at my tile palette. I pull it up to over here on the side, right? And I want to select kind of an area in the world where it's going to be created. So I'm going to kind of take the corner palette. Notice that I'm using the brush, and I'm brushing it here just below where the camera is on the left-hand side, outside of the screen. That's my endpoint. And then drawing it kind of across the screen all the way to past the middle, right? And with an end cap. So kind of a longer starting platform is what I'm giving you. A place where the player can start off and they don't feel nervous. An end cap over here with the end cap over here. So kind of all the edges. Bottom of the platform is going to drag here, and the corner over here plus the edge over here. So I'm just going to select different parts of it. With the middle part, it's going to be filled in here. All right, so that's the first platform. You can see what it looks like down here, right? And that's not so bad. What I also want to do is I want to change the main camera's solid color from blue to black. So let's change it that way so that it looks black, so it doesn't distract from what it looks like. So this is what it actually looks like. This is what we're planning to do. Okay, so part of the platform in this case is off screen. Awesome. What I want to do now is add a player object. So again, inside of Sunnyland, there are, in the Sunnyland assets, there is a sprite for player, and player has an idle state. The player is a little fox. That's what they are. So you can definitely use this. If you don't like the fox, you can also, for our examples, you can also use in Sunnyland Woods, there's another sprite for player, and they have an idle for a little squirrel. But I find that the fox is better because it also has a climb animation, okay? Which if I want to climb upstairs, the fox is a little better than the squirrel. Okay, I think it's a fox anyway. Looks like this. So I want to grab all of the textures, right? All of the sprites for the under Sunnyland artwork sprites player idle. I want to grab all of these. And what I want to do is I want to change the pixels per unit back to 16, just like we did for the assets, the tile map assets that we had in here earlier. Again, clamp, no filter. Resize the algorithm is going to be bilinear. and we're going to click on apply. And we can leave the maximum size to what it is. Cool. Awesome. All right, so I don't need all of these because I'm not going to do animation right now. I'm just going to grab the player idle and drag them into the world. Okay, notice that they appear to be on the platform because of where I position the platform. I'm going to actually grab this player and move it a little bit up so we can see that it's kind of hovering over the platform to start, somewhere like that. And I'm seeing kind of a height of 3.5, let's say, okay, just to be the same as you, okay? So the player, when you would run it, it would look like this. And what we want to do is we want to rename the player idle to player. We also want to change the order and layer of the player to match the platform. So it should be 1 for now. All right. The player can't fall because it doesn't have a rigid body. So let's add a rigid body. So rigid body 2D. Oops. And we also will add a collider. And the collider that we need to use for the player for now is a Capsule Collider, right? I'm going to get back and clean this up in a second. So for the body type, it's going to be dynamic and rigid body 2D. You can also have static. We'll create that later on. Our gravity scale is 1, but we're going to see that that's probably not right. We'll leave this as is. And let's change our Capsule Collider so that it kind of hugs the player a little better by just moving the capsule right against its pixels. Something that looks like this. Okay. It's not quite right because the center of the player is probably right here. So we can probably even do it to hug it closer. The top doesn't also have to be that high. We can kind of pull it in like this. So that's our Capsule Collider. And in order for us to collide with the platform, the world itself has to have a collision system. So I'm clicking on the platform layer and I'm adding in a new platform collider or tile map collider. Okay. Now there's other things we're going to do, just not yet. So if you don't need to skip ahead, just follow me. You're going to be fine. So if I was to run this right now, then you're going to see our little player kind of fall from here and hit the platform and roll over, right? Because, well, if you turn on there, if I go back to the player and I turn it on, you can see that the collider, right, is kind of that kind of shape. You can see that that's why it looks like that. If I actually was to do it again and run it, you can see what's going to happen now. As it hits, it kind of rolls because of the way the platform works, right? The collider is going to roll across. It's going to use physics to do that. That's nice, but it's not what we want. So what we're going to do is in our rigid body, we're going to go to constraints. We're going to turn on freeze rotation on the Z-axis. And now when we run it, you're going to see that the player falls, but falls directly on and stops. Okay, doesn't roll because even though it's kind of pivoting on this simple place right here, I'm not allowing rotation across the Z-axis, so it freezes it like this. That's nice. But we noticed also that the falling rate is pretty slow, right? Like that is a slow falling rate. It's like floating. And so what we want to do is change this around. So I can increase the gravity scale to something like 10. But there's a problem with this, right? The problem is that the amount of force that I would need to exert to make an object fall, to make an object go up, would be 10 times as much, right? Because my gravity scale is like 10 times gravity, 10 Gs, right? So instead, my mass should also be compensating. Let's make this 0.1. And so again, falling wise, it's not going to go down any slower, right? Same speed. But when I push the mass, it's going to be, especially across the surface, it's going to be a lot less force required, and to compensate for the gravity scale. Cool. So that's the first thing we've changed. All right, so rigid body's done, Capsule Collider is done so far, and we're pretty good. Let's add some player movement, and the way to do that, of course, is to add our new script. just going to close these up. In scripts, I'm going to make a new C# script called player behavior. Global gravity, but that means for everything, right? And Michael, sometimes I don't want my entire gravity change for the entire game world, just for only part of it, the player, right? For other parts of gravity, I may want gravity to work a little differently, and that's why I'm doing it this way. But if you feel that you want to do it that just like that, you can. It's not a problem. All right, so I'm going to double click on player behavior. I haven't attached it yet to the player. And let's think about what I want to do. So again, what I'm thinking about is I want to start configuring the player data, right? And I want to think about some ways of controlling the player. I'm going to control the player with some kind of force-based kind of movement, because I want to be able to jump with force and move with force and all that kind of stuff. So what I'm going to do here is I'm going to add, when ReSharper lets me, I'm going to add a, come on, I'm going to add a header, and the header is going to be called movement, and I'm going to have a public float that is horizontal force, and I'm also going to have a public float that is vertical force. Again, you might do this differently. And what I want to also have is a private reference to a rigid body 2D where I can start using this force. So we're going to call this rigid body. And I'm going to say that rigid body is equal to get component rigid body 2D to make a reference to the rigid body component that I have in my player. Yeah, I love it. I think it's great. Kira says sometimes you want to edit the gravity scale on the player via a script. And for example, you can lower the gravity scale where they're holding the jump button to make them jump higher instead of applying more force. That's great. I love that idea. And I think that's fantastic if you want to modify it that way. I'm not going to do that today, but I think that's an amazing idea, right? Again, it's these little nuances when you're playing around with your player behavior or player controller that makes it really nice, right? So that's really great. I love that idea. Okay, so rigid body 2D, and what I want to have is some kind of move function, make it private, and which is going to be called every update. Again, I can use a physics update instead of like a fixed update instead of an update, which is more deterministic, or I can use an update which spams as much as fast as it can. But then I'm going to scale that with a time.delta time, right? So let's set up our variables here at the top. So we're going to say, I'm going to just do it slightly different. I'm going to say something like var delta time, because I don't want to say time.delta time, is going to equal to time.delta time. So I'm just going to create a little alias, just call it delta time. It's a float. And what I also want to do is I'm going to basically say something like I want to get input for X, Y, and jump, because for X, let's suppose I'm going to say float X, which is equal to the input.getAxis raw, right, like we did before on the horizontal. We've kind of done this before from the first half. And I also want to have a Y where I want to say input.getAxis raw on the vertical. So what if I want to push my player up, but I don't necessarily want him to jump? So example would be going up ladders or something like that, okay? And the last one is something like a float jump, where I'm going to say input.getAxis raw jump, Okay, so that's for this. All this stuff is for my keyboard input. I also need some kind of, like we've done in the past, some kind of world touch that I want to do. So I'm going to say something like a vector2, call this world touch, which is going to be equal to a new vector2 object, just to start off, an empty vector2 object. And this would be for touch input. And then what we can run for touch input is a for each loop for every touch and input dot touches, right? So all the touches array, I want a touch. And I can say that our world touch is equal to, and we're going to use the main camera. So camera dot main dot screen to world space, screen to world point. We're going to pass in the touch dot position, which we've kind of done before. So that's world touch. It's going to tell us wherever we touch is going to give us a unit, again, based on the position of the place that I've touched. That's going to keep track of touches. Again, I'm not going to complete the touches thing yet. I just want to think about ways of getting input from getting touches. Okay, this is kind of a way of doing that, right? So I've got this right now. I'm going to focus on this part right now and then go back and fix my touch input later. All right, so this is good. This gives me input, right? One thing that was mentioned earlier was maybe what you want to do is, kind of get input separately and then do the move separately. So this is two things, right? One thing is getting input, right? And the other one is it's actually going to complete the move down here, right? So some stuff to think about. Let's just put it down together now as one. So here, what I'm going to do with the move is I want to think about taking my rigid body 2D, right? So it's rigid body, lowercase r, dot add force. And again, what you can see is there is two ways of doing it. I can add force, or I can add force with a mode, right? Adding force with a mode, what it does is it forces us to do it a certain way. And for now, what I want to do is let's just use keyboard input on the x-axis alone, just to see if we can move it left and right. First things first, right? So let's try and move it at all, right? So I'm going to say something like, well, I have a force, and let's just use vector to right, and then multiply by some kind of horizontal force times delta time. What we can do is we can break that down. We can say that our horizontal move force is equal to our horizontal force that we're getting from input from our player, right, or the user, multiplied by delta time. Okay, did I put in that? Did I call it something different? Delta, oh, erg. That's terrible. No one even corrected me. So I want to multiply it by delta time. So horizontal force by delta time. That's our horizontal move force, right? And then I want to multiply the horizontal move force by, when we add force, I want to do that, horizontal move force, right? So that's what I want to do. So multiply by horizontal move force. But what that would do if I did this, because move right, that's okay for now, but we're going to have to change this later on. Okay, so it's kind of like vector to right, and we're going to add some move force on the right to move us where we're going to go. Let's test and see if this works. Let's plug this into the player. I can also multiply my force. It says, Kara says, when using the new input system, most of your input comes to you in the form of callbacks. So it calls on move function when the move input is actuated. Yeah, it's pretty cool, actually. And you can also multiply your force being added by your mass if you want to take mass out of the equation, which is pretty awesome. All right, but we're using the old input system. So let's move on to how this would work first. And then Eventually I'll get to the new input system, but I want to talk about this one. It's great that you know that. All right, so right again times horizontal move force. We want to connect this to our objects in Unity. So we have our player. There we go. And I want to connect my player behavior to that. Awesome. And let's add a simple horizontal force. Let's use just one. And let's see if that's enough. It's not enough, right? We're going to see what it does. Let's run this thing, and it should give us some input, right? So again, no input when I press the buttons. Let's add horizontal force. How about 10? Nothing. How about 100? Right? How about 1,000? Yeah, that's a lot, right? So that's something that we have to, we have to figure out what's the right amount. 1,000 is definitely too much. Let's try 500, and let's try that out to move us around. Automatically, it looks like it's bouncing us to oblivion. Why is that, right? Well, remember that our horizontal move force is taking horizontal force times delta time, but we also have to multiply this by x. So x times that is going to give us our horizontal move force, which is something we forgot to do, or I forgot to do. And no one said anything again. So it says, no, I meant right now for the mass thing. Instead of reducing the player's mass to account for gravity scale, you multiply your force by being added by your mass if you want to take the mass out of the equation. Force being added by your mass. Float delta time, float horizontal forces, delta time, float mass is equal to rigid body mass times rigid body gravity scale. Oh, I see. And you multiply that by mass. Okay, that's definitely something that's neat. I like that as well. And how does that work for you when you're working it? So let's try it. So let's try this out. So 500. So I can move left and right. Pretty good, right? But it seems to go really quick. And what you can do to reduce this is inside materials. Let's add a new physics material, 2D. We'll call this platform. The platform material, right? And the platform material can be added to your material right here, Tile Map Collider 2D, or which is your world, right? This is your platform, right? So again, add it on there, which gives us a little bit of more control. We can add friction. Let's try some bounciness and see what it does. So if I try to add bounciness of 0.2 or even 0.1, when I land, sometimes I get a funny little jitter, right? And what it's trying to do is trying to bounce, but it's bouncing at such a low amount that it's causing jitter. If I go 0.6, then you're going to see it's going to bounce all over the place, right? Right? Kind of bounces and jitters is what it does. Why? Because it's based on my new gravity scale. So going back to what Michael said earlier, this is because my gravity scale is so wacky, right? And I can also reduce the friction and move this down to 0. And if I was to do something like this, let's see how that looks. When I move it down, maybe 0.2 is too low. But it's not bad in terms of overall, the way it works. We do want to reduce it over time. And the way we did that over time last time is to multiply velocity by 0.99, right? Where we can say something like rigid body velocity. I didn't do this for the first half. Rigid body dot velocity, and then times equals to 0.99, right? Which kind of reduces it a little bit. You can try different numbers here to see that it changes even more. So that way it drops. But if you did this, even for falling, this would take effect. So you only want to have this in place for moving. All right, so we'll talk about this later. So let's just comment this out for now. But we do want it to kind of slow down on its own, just beyond just regular friction. All right, so nice. Everything is good. We've got some motion. and it's not so bad, right? It's not so good, but we've got some motion right now with our character. And if I hold it down, I can get pretty fast, but it's not terrible. Okay. Awesome. So some kind of motion with the player. Let's now add in some jumping capability. We'll add a vertical force starting off with about the same, 500. Let's see if that's too much or not enough, right? And let's go back to what Kira was saying here for a second. So first, let's try the other dumb way, which is float. And we can say something like jump move force, right, is equal to our jump multiplied by the vertical force multiplied by delta time, right? Can't spell delta time with anything today. But now if I want to do both, I can't do vector to right. Instead, what I need to do is something different here, where I can do something like add force, a new vector to object, and trap in my horizontal force as well as my jump force. Okay, so that kind of does it right there. Now that's not including what Kira said, which is you're going to take your force and multiply it by your mass. After you have what you're doing is you're actually scaling your mass across your gravity scale, whatever that is. You take mass, like it says, out of the equation. And so what she's done, I'm just going to put this down in here for a second, is there's another unit of measure called mass, which you can say that you multiply that by rigid body dot mass, and you multiply mass by your rigid body dot gravity scale, which takes mass out of the equation, and then you just multiply this by mass at the end. Correct? Are we good, Kira? Okay, let's see how this works. If it works any different, better, the same. Let's see what happens. So going back to this now, if we run it, we have 500 vertical force. Let's see if that's enough or too much or whatever. So first, let's see if we can move. It's movement unaffected. We do have a bit of skipping, but that is an effect of what we've done. And now, well, if I hold it, I can go down here, that's for sure. But I can keep holding it until it flies up to oblivion. So that's kind of something that we note. And why can we do that forever? We can even do this forever. We can keep moving forever and ever. Why? Because I'm not limiting ourselves based on being on grounded in any way. Okay, so that is the next piece of thing. Before we actually test our jumping, right, which we really don't know how it would work if we were grounded, because we only want to have a touch point for grounding. So now what we want to do is we want to have a new function that's check if grounded, check if grounded. We don't have a function like this. We're going to create one. And we also want to have up here a public bool, which is grounded. Okay, so we want to kind of show if we're grounded or not. And down here, the stupid way to do it, and I kind of talk about this as a stupid way, is using an event. So you can use something like a private void on collision enter 2D, where we say collision 2D. This is terrible, but I'm putting it down there because I've seen people do this as well. Or you can say is grounded is equal to true. This is a great way of testing it anyway. And then private void on collision exit 2D. We can say collision 2D other, and then is grounded is equal to false. And this creates a relationship between touching and not touching any object and having this work. But the problem with this is, and let's see how this works. We can say that the only way that we want any kind of input whatsoever, even delta time, is if I'm grounded. So if is grounded, then and only then do we want to get all this stuff working. So we can do a check to make sure that we're grounded, or otherwise we're not going to get this working. Now we can put this rigid body velocity times 0.99 to slow us down because it's only going to work when we're grounded, not when we're falling. Okay, so that's something we can put in there as well as a scaling factor. That's what that is. Scaling, stopping, if you will. Hack. Okay, and that's beyond what we're doing. So now it says that I've used the wrong one. Check if grounded does not exist in the current context. Did I miss something? Oh yeah. Let's make a function, a private void check if grounded function that's just not doing anything right now. We're going to replace this stuff with something that's in there. All right, so let's go back to Unity and we'll go to the player. We can see now that the player has an is grounded Boolean. And now we can actually check something like, right, exactly. That's why it's bad. So it's really bad because I'm grounded. It shows me I'm grounded, but if I press space, I'm getting a sense of I can only press space when I'm not grounded. And that's okay, but it's true that it looks like we need more vertical force. All right, so again, I'm not scaling here. Let's add something like 1,000, and let's see how that looks. So you can see that I have some, when I kind of click on it, right? And the other one is maybe 2,000. Let's try 2,000 as something like we can use, right? We can get some kind of bounciness happening where if I time it right and I'm grounded, I can get a bounciness that looks pretty good. That's just adding force to my bounce. Okay. And we're just going to get a rough force altogether. Not the best way of doing things. And you can see that we have some kind of issues because it's detecting the collision detection before that's happening. And even if I put more values to this, let's say 3,000 or 10,000, right, as an example, we can get some odd effects. And where the odd effects come really into play, let's remember that value, 3,000, is if I was to draw something else in the tile palette. So if I go to platformer, get the tile palette, and let's put something else in there instead. Let's suppose I have a block like this, and I put it like something like this as an example. And now I can really have wacky effects because these are all blocks that are in the same view. And if I go right here in the corner and jump, I'm going to get a crazy jump. Guess what? Because I'm connecting both with this block and with this block. That's really bad. And the other thing that Kiera said, which is really bad, is what about if I'm right at the edge, I can jump and I'm barely connecting, and that would be bad too. All right, so those are all real good reasons why collision detection is not the right approach for being grounded. So yes, nice idea, Tom, but no, not going to work. Okay, so instead we're going to use a raycast. That's what we're going to do. We're going to do a raycast. And what I want to start doing is I also want to start thinking about how I'm going to do this raycast. One of them we can use is a raycast, an actual line. But the problem with the line is, again, if I think about the player as an example, and let's just draw the player down towards the platform a little bit. So let's say here's the player. Let's suppose I'm at the platform. I go over here. And in the player, let's suppose I have a raycast that I want to draw. So I draw a line. I'll just use my annotator here for this to explain what I'm doing. I draw a line that goes down, but what happens if I can connect with the ground? This is a way of raycasting. This is okay, but what happens when I go up a slope like this, right? Then what would happen is sometimes, depending on how I'm raycasting straight down, I'm not going to connect with the ground, and then I won't be able to move up the ground at all. I won't be able to stop, right? Or I can simply raycast in front of me, right, slightly. But then what happens is if I raycast in front of me slightly, then what happens is that when I'm hanging off the edge of let's suppose this is the edge of the platform, right? Then I can get hung up and I can't move. So it means I can make another ray that goes this way, and that's bad, right? And other things I can use raycasting for. So this can be limitations on using just a simple ray. So instead of using all those things, the thought is to use some kind of circle cast, right? And the circle cast that we want is going to kind of start from, well, not like that. Let's try drawing it properly, Tom. Something like this, where the circle cast is kind of touching the ground. It should be smaller than the collider, the capsule collider. And as it touches the ground itself, similar to what we did with the colliding system, right, it's going to detect that this is a platform. So here's the platform. And it only will collide with the platform compared to colliding with anything else. Okay, that's the idea behind it. Okay, so only with the platform and nothing else. Okay, so how do we do that? Well, there's a really cool function that we can use called Raycast, Circlecast is what it's called, right? So that's something that we want to use. And I described that earlier today in class. It's a bit of interesting code, but let's talk about it. And the problem that we're going to need is where the circle originates from. We can't originate from the center of the player, which is like right here. That doesn't make any sense to originate from here because it would be too big, right? It'd be too wide for the circle. Circle's going to have a radius, right? So we're going to have to originate it somewhere down in here, which means we need an offset. Let's think about this as the ground origin or ground detection origin or something like that, which means we need another, child. We're going to use an empty object, child object. We're going to call this ground origin. And let's put a little marker on it so we can see it. So it's a little marker like this. This is the ground origin right now. Let's make it so it's green little marker, right? And let's make it, like a diamond like that. And what I want is in the editor, I want to be able to see how big it is when I make it inside code, right? And in order for me to do that, I want to do a couple things, right? I want to start thinking about what the ground origin is going to look like. What I really want, let's use something built into Unity called onDraw gizmos, right? On Draw Gizmos, you can draw your own custom gizmos in the editor only, where I can say something like, hey, gizmos dot color. Let's make that color equal to color dot green. Right, I want to make a green color. Everything's going to be green. And my gizmos dot draw wire sphere, so it's in 3 dimensions, is starting at my ground origin, right? So let's get another transform, right, which we're going to make public. So a public transform that we're going to call ground origin, And ground origin is going to be, we're going to say that let's start at the ground origin, and I want to have some kind of radius, some kind of ground radius. So public float ground radius. Why am I doing this? Because round radius, again, I want to be able to make it in the editor because the more I put in the editor, the better. And ground origin is a transform, so we need to make it ground origin dot position. This isn't going to appear right now because we haven't defined ground origin or ground radius. So if I go back to the editor, right, and it's going to complain. That's okay. We're going to fix this because in the player, we're going to say that the ground origin is this little sub game object, and the ground radius is going to be something like 0.4. Now, instantly we have a drawing that is appearing in the editor, nowhere else, it doesn't appear in the game, that shows us what the ground origin looks like. So what I want to do is I want to pull this ground origin so that it is, so that it is closer to the ground, like somewhere down in here where the player's feet are. And I want to compare it to where the Capsule Collider is. So here's the Capsule Collider. And you can see that the Capsule Collider is kind of off. Like it just tells us that. So we want to kind of bring the Capsule Collider towards the center of the player, like so. Something closer. And the ground, right now, my ground origin is at 0.608. Let's bring it up 0.62, right? Negative 0.62. When if I look at the player, it is touching the ground, but it's smaller. It's kind of narrower. That's why it's 0.4 than the the collider, the capsule collider. So the capsule collider in this case down here is going to hit the blocks first before the origin hits. Okay. So that is what it's going to look like, something like this for now. All right, cool. So we've got where it's going to be in it, and we've got a little circle to give us help to know where it's going to be at. All right, so we can visualize what this is. If we want to make it lower, we can do that manually later, if that's going to help us. Going back to our code then, we can start inputting a bit of our code like this. We can say that I want to generate a raycast hit 2D. We're going to call this thing hit. And we're going to say that we're going to use our physics 2D class, and we're going to call for a circlecast. Circlecast is going to take the ground origin as the origin. That's the little offset that we just created, followed by the ground radius, right? Followed by, the direction, which is vector 2D down. We're going to look down, followed by the size or the distance, which will be again the ground radius, followed by some kind of ground layer mask. We don't have the ground layer mask. Let's add it in. So ground layer mask, let's add that in, public layer mask. We're going to call this ground layer mask, right? Which we're going to use down in here, ground layer mask. Circlecast. And why am I getting issues? Physics 2D, it's going to hit. I'm missing something. Oh, this should be ground origin dot position. How about that? Ground origin dot position, ground radius, vector 2D down, ground radius again for the distance, ground layer mask. Okay, so that gives us a hit. And what we want to do is we want to use a ternary operator. We want to say that is grounded is equal to, let's take it, if we have a hit, then it's true, otherwise it's false. We can also just say, if a hit exists, that's what we're saying. If the hit exists, then then is grounded is true, otherwise it's false. But we can also just remove these things altogether and just say if a hit exists, true or false, then it's grounded, right? But I like to put it this way for a reason. Okay, cool. So this is the is grounded check. Is it grounded? Then cool. Well, what is ground layer mask, right? It's going to check a distance below my origin, right? So whatever the ground origin position is, if I'm not wrong. Okay. So let's check. So that means that you'd be over here, you're saying, right? Well, we can check that. We can check that and see if it's true, because then we'd be able to jump when we're in the air, right? Or we'd be able to move in the air closer to the ground. That's what we'd be able to do, right? So we can check that. So one thing we can do is when we look at the player right now, is there an error? Is there an error? Ground layer mask, save. Yes, I just didn't save. So we should get a ground layer mask, and the ground layer mask shows us the mask or the layer that we're connecting with. We don't have a layer for the platform. Let's make one. So again, here I'm going to add a layer. I'm going to call this layer the platform layer, and then I'm going to save. Go back to the platform layer and assign it platform. And then here inside of the player, I can select that I only want to collide with the platform layer and nothing else. Okay, so only the platform layer am I going to generate a collision. All right, let's try that out. Let's put our player back where they're supposed to be. So kind of over here and up here, around 3.5. All right, let's see what happens now when they fall. And does it detect is grounded? So yes, right? And if I press space, then we're seeing that it kind of reacts nicely. And I'm trying to say what Kiara's doing. And let's suppose she's right. That's a bug. So let's say the ground radius, the distance should be 0 then, right? If what you're saying is true. And if that's true, let's see if it still works. Yep, you're right. So it should be 0 if I'm not wrong, right? Oh, well, I don't know. Look at that. It says is grounded is not is grounded anymore, right? So this has to be a distance. This is the radius. So this is how far it goes on the right and left. This for the circle, and how far it goes down, because you can make a circle kind of appear a little bit longer than what it is, right? I believe, if I'm not wrong, that's why we put the radius in here twice, ground radius. Try with 0.1 for feet. Are you talking about the ground origin or the distance? Because that's exactly what it is. Ground radius and ground origin the same. Ground radius and collider before hitting the ground check. Okay, maybe that this is too much then. The ground radius should be up higher, right? But anyways, if you notice, if I go to debug mode, are you talking about debug in the inspector? Debug in the inspector. Script. Again, it might be too much in terms of that. See what that does? See how it's working where it's I can bounce, 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 and then spam. And then occasionally what happens is it kind of collides with both things. Look at that. That's crazy. You should never do that. Yeah. But it still has an issue. And let me talk about that issue now and discuss why it's still happening. Why is this still allowing you to spam a bunch of times and blah, blah, blah. All right, because it's not using anything else. It's using is grounded. This is nice. But the problem that we're having is it's allowing you to kind of double jump sometimes. So why is this happening? Well, it's when you jump, what's actually happening is this thing is colliding with the ground twice. And why? Because each of these blocks, right, as an example, has their own set of colliders on them. Interesting. So this way you're getting multiple hits for your, the same problem that we had before for the platform layer. We're getting multiple platform layers hitting. Look, it's hitting right in the middle, dead middle of these two blocks, and they're both colliders. So to fix this problem, this is what I didn't have a chance to do earlier today, is you need to add another type of collider. So onto the platform layer, let's add another type of collider called Composite Collider. Composite Collider adds a rigid body 2D, and what you can do in the tile map collider is you can use by composite. Check that. Notice now that it only has one collider for everything. Kind of connects all the colliders into one, which is what we want. Okay, so again, tile map collider, it used by composite. Composite must exist, but we also have a rigid body 2D, and we have to change the body type from dynamic, because we don't want the platform to fall away, to static. Okay, and when we do that, and if I press play, now we should have a different effect. Should. Let's see if it works better, worse, the same than we had before, right? We shouldn't have that weird, jumping effect, because what's happening here is we're adding force twice when it comes back to the bottom. See, what's happening is we're gathering force up. if I'm just jumping and doing that. But the great thing is that now, right, we can jump and jump. So double the force. That's what's happening here. And that's because of kind of the effect of the physics and everything else that we put into our player. So player and using the gravity scale. But what if, and I'm just going to put it out there, and I know that people may disagree because we tried this because of the suggestions we had earlier today too, because I love suggestions, right? I'm using a update, but what if I use fixed update? If I use fixed update, then I don't need delta time because delta time doesn't allow me to spam, right? Which means I can end it here, right? And let's see what the effect is going to be with this. Does it give me better? Is it worse? Do I need to use more force, less force, the same? We can see what the difference is between a fixed update and an update. Let's try and see the difference. So again, if I run it, so no more update, it's only fixed update. And let's see what the effect is going to be now. So, whoo, right? Why? Because now my force really makes a difference. Huge. In my fixed update, I can use a lot less force than I did before. Let's move these values back down to ones just for a second. Okay, so I'm going to use fixed update now instead of update. Let's see what happens now. So can't move. 10 moves this good enough. Look at that. So 10 is okay. And what about 20? Or let's try 5 first. So does 5 jump and all? No. Let's try 20. That's pretty good. And we're getting a solid amount. Even if I do one of these, spamming is not allowed. I'm not going to get a weird interaction. It's going to be very similar every single time. I like that a lot more. But 20 is not enough. Remember, we want to jump at least twice as much as me. So let's try 40. Let's now watch the distance that we're going to go. That's the important thing. Is that too much? Take a look at 1, 2 levels, right? So if you measure the person with what this is here, let's draw it out with our annotator, right? And so we can see what it is. And this is kind of the tools we want to use for this. Let's use a box annotator for this. So I want to kind of say from here to here is the height of the player, right? And I want to draw another one of those here. So let's just like estimate what the height is going to be, something like this. So that is a regular jump, right? And we want to do a double jump, right? Maximum, that's too much. Something like the same as this. So something like this. That is the maximum height we want to reach for the player. So this part here, this should be the highest level it should jump. Does that make sense? Because that is a reasonable amount for the game as per our rules, right? That we kind of set off earlier. Now let's see what this does for us. Can we jump too much? Right, so see we're jumping way above that level, right? So 40 isn't quite right. Let's try 35, right? That's not quite enough. Let's try 38. And again, I'm using trial and error because I want to reach that kind of height. See how he's just jumping there. Occasionally he's doing a little bit more. And this is where we can play with the, with this stuff. And occasionally he'll get there, but not quite often, right? So I think 38 might be best. If you're really concerned, if you want to make it an even number, 40 might be the best. It's a little higher than we want, right? It's a little higher than where it's going to be, but that's probably the most where you want to go to, between 38 and 40, okay? Make sense? Based on his height, I'm going to try, it's actually too high, but anyways, because I've kind of not really measured things correctly, right? It's probably closer to this. Maybe let's try 35. Let's try remeasuring that stuff. So one more time. Again, measure twice, cut once. So let's try that one more time. And again, I want to make it so that we stick with the rules, right? That's the idea. So, I mean, people have done design for a reason, right? It's not like, there's been research involved, right? So again, let's try and make it so it says, I'm going to try and use my eyeball here as much as possible and try to make it so that it is fairly even. So kind of there, and this is the top. So I shouldn't be able to go past this point. And let's just Try that again. This is 40. Yeah, so it's way too high. Let's try 35 again. Almost there. Something like between 36 and 37. Yeah. Yeah. So again, I think 37 in my second attempt is pretty good. 37, I think, is pretty accurate based on our height. Okay. Using fixed update, not update. Using update, the problem with update is you spam, even if you scale it with time.delta time and you do your mass trick to reduce the amount of force that you need, like Kira's talking about, it still has this really weird effect, especially when it comes to physics detections and so on, which is what we're doing with our ground update. All right, so remember 10 and 37. Let's put that back in here, and we can put the scale in here as I'd like, 10 and 37. Yay, we've got our grounded update, and now we have our motion. Okay. Just going to clear that up. Any questions so far? This is as far as I took the class in the first section, right? So things that are left, okay, we've moved this way. I want to be able to change direction. So when I move, I want to be able to make the player change direction. There's a couple ways to do that. Inside the player themselves, they have a sprite renderer where you can do a flip. But the problem with this is, let's take a look at the Capsule Collider for a second. When I do a flip, I also flip, right? Not just the player, but the Capsule Collider too, right? I want to be able to do that. And that is a challenge. So I can't just use flip. Flip isn't good enough, right? I want to make my own flip. And I'll talk about this in a bit. So when I move to the left, I have a direction I'm going to. When I move to the right, I have another direction I want to go to, and I want to detect the direction that I'm moving in, okay? So let's think about other things that I want to have. So I want to move, right? And then I detect if I'm grounded. That's nice, right? And after I detect that I'm grounded, I want to flip my, my position, the way I'm kind of looking. If I go this way, I'm going to flip that way. If I, depending if I'm moving at all, as an example, I want to be able to flip my position. Okay, let's try that. So back to the drawing board. How do I do that? I'm going to have, eventually we're going to have animation, eventually. So what I want to do is I want to have another function. Let's put draw gizmos like way down here. So this is like kind of like utilities, right? But down in here, I want a private void, something like, actually it'll be a float that it'll return. We'll call it flip animation. Okay, flip animation. We'll pass in the X value. So we have to pass in the value that we're getting. And what we're going to do is we're going to say that whatever X is, if X is greater than 0, so if we have a positive motion to the right, then we're going to return 1. Otherwise, we're going to return -1, okay? If X is greater than 0. And what we can say is that we can say transform dot local scale, right, is equal to a new vector3 object where I want to pass in X and 1.0f. Okay, I don't have to define my z-axis. It just stays as it is. All right. So, and I'll talk about why not just put X into local scale, right? Well, that means that X could be other things. It might not be exactly 1, right? Or -1. And I don't want it to flip somewhat, but not the whole thing. So to prevent that, I'm scaling it. So it must be either 1 or -1. That's why I'm doing this step. So depending on direction, scale across the x-axis, either 1 or -1, which is what I'm doing here. Okay, so that's why I'm cleaning it up. And then I want to return X, because that's what I want to be able to use this thing later on. So I kind of get X from somewhere and I return it. So I'm going to make a little function that allows me to do that flip animation stuff. Okay, cool. So what I want to do is, when do I use this, right? When do I use this? Well, we have X here, right? And really, what happens if there's a case where I wouldn't want to flip, where X is 0. If X is 0, I don't want to call flip animation, right? I don't want to do that. But if X is not 0, then I will flip animation. You can do it anywhere in here for now. Let's just put it right underneath our get access. So we're going to say something like, check for flip, right? We're going to say flip animation X then is something that I want to do where I'm going to return X back out. I don't have to do this. I can just say flip animation or whatever, but let's just return it back out. So we're going to pass it through flip animation. And we're going to pass in X. All right. So that passes it through. Okay. And it's only going to be done if and only if, right? We're only going to do that if I need to flip. I'm going to say if X is not equal to 0. So if X is something else other than 0, then I'm going to flip animation. Otherwise, we're not going to even bother with that. Okay. Lots of ways of doing this. You might also think about getting a reference to the, like I said, the renderer, right? The 2D renderer, here, or sprite renderer. I don't want to do that. I just want to use literally local scale to flip everything the way it's going to go. So let's see how that works. So again, if I run this properly, and if I press play, maybe it's going to work, maybe it won't. Let's take a look. So here, and now I can move it, and you can see that I flip, and everything flips with me. Okay, so now it looks like I'm moving around, so I can go here, and I can go there, and now it's looking a little better than what it did before. Finally, and this is the last thing I'm going to do before we move on, is I'm going to add in our animation system to this thing, and then we'll stop for the day. So under Sunnyland, inside of our artwork, we have our sprites, and inside of our player, we have our idle, and we have these idle sprites we've been using before. I used the first type of idle, which was just the simple animation, the first frame of the idle animation. Now what I want to do is I want to take all these frames and bring them in. So just pull those in. It's going to ask me to create a new animation clip, and I'm going to do, under assets, I'm going to make a brand new folder called animation. Actually, let's put it under the sprites folder. Just thinking about it again, it's probably best to do that. So here under tile maps, we'll make animation. And inside there, we're going to call this new animation the idle animation. So we'll say player idle. And when I click save, it's going to create that animation state, right? And the animation controller. I'm going to fix this in a second. Let's get rid of the player now. We don't need it. It's literally just there to create my animation. And I'm going to go into the sprites animation, and I have two pieces, the animator controller right there. So this is the player animator controller. And I have my player idle clip. Player idle clip. All right, so that's what I've done. Player idle clip, player animation controller. I can attach my player idle, my player animation controller to the sprite renderer, right? But what I need is an animator controller. So add in an animator controller, which is the animator. Let's move the animator way up. So move up and move up and move up. I want to make it right underneath the sprite renderer. And I'm going to drag in the animator controller in there. There it is. And what this is going to do is when I press play, by default, the only animation that's going to play is the idle animation. It even plays when I jump for now. And we're going to talk about animation and how I'm going to put the animator together later next week. So far, we've got pretty good. We've got a bit of control. It's not perfect, but it's much better than it was before. Okay. And if we go over here, it doesn't kind of double jump, which is not what I want. Take a look at how it kind of crosses the barrier here, sometimes below and gets repositioned. Look at that, right? It doesn't double jump no matter what. Even if I'm kind of on here, it won't double jump, right? Even on blocks. All right. So again, we're missing lots of stuff, but we are on our way to do our first piece. All right, great. Let's save this and file, save project. And we're going to move with this project going forward. So we're going to update this project over and over again as we go. Let's turn this Unity off and let's put this up on GitHub. Any questions while we do that? Or comments? Say version 1. Well, added, we'll say basic player movement, which is a better identifier. Questions? So again, I think going back to our lab, what we've talked about right now is, this is for lab 6. So what we've done is we've talked about some basic physics, rigid body physics. Thank you, Kira, for all your help. And the idea here is that we want to use a raycast, like we talked about, instead of some kind of collision system. And sphere cast, or a circle cast in this case, is probably one of the best ways that I've found that's more consistent with detecting ground. If I can detect ground, then I can do a bunch of stuff. Things that are missing, all right, that we still haven't done. Let's bring back our Unity project for a second, all right? We don't have a death plane. We need a death plane. So when we die, we kind of go back to a spawn point for the player. That's missing. We're going to add that in next week. We don't have any other animations for jumping or crouching or anything else like that. We have no other motion, just very basic player motion. We don't have that. We don't have another platform to test with. We don't have that, okay? And what about if I wanted air control, right? How do I add that in? So a good example of that is, well, I'm jumping, but what if I want to, when I'm jumping, I want to kind of change directions in the middle of my jump. So I want to do that. We also haven't implemented touch controls. So if I switch to touch controls right now in the simulator, I want to be able to add some kind of touch controls in order for me to be able to move around. How do I do that when I'm jumping? What kind of touch controls do you recommend? Sometimes it's a jump button, right, as an example. And sometimes it's just some kind of controller. So again, if I want to jump to the right, top right, then I would have to pull maybe my controller to the top right, which would make me jump in that direction and land, right? If I pull to the top left, maybe that might be a control scheme, then I would jump to the left, right? Jump to the right, jump to the left. What about pushing up? Then I would jump up, jump up, jump up. If I go to the right, then I'm okay. The problem with that is that I'd have to be very accurate in terms of where I'm pulling my controller, right? Because if I'm just slightly up, I'm going to try and jump, which is terrible. I don't want that. I want to be able to cleanly go to the right and left and only jump when I need to. And if I can do that with one hand, that would be awesome. Okay. So how would I do that? Any ideas before we move on? I know we're running overtime a little bit. How do I do it with one set of controls? What can I do? Well, one way to do it is I could use like I said, a waypoint system, where I can kind of click on the screen, and when I click on the screen itself, it's going to move my character towards that position. If I click up, it's going to try and jump. But if I click to the right, as long as it's to the right, but not above my character, maybe a certain amount, some kind of threshold, then again, it won't jump. It'll just move to the right or left. I can accomplish the same thing with some kind of controller. If I don't move like directly in some kind of thing, it's kind of tricky. But with one control to test with, it's pretty tough. Could also use multiple buttons, right? That's also good. But that's kind of something that we have to talk about another day. All right, questions at all before we go? All right, that's it, guys. Thank you so much. I'm going to stop recording this on YouTube now, and we're going to get back to what we've been doing, which is I'll let you get back to it. And for Friday, again, if you just followed along and you did what I did, then you're going to be pretty good to go for your Lab 6. It's just homework practice for what we're doing here. All right, let's stop recording now, and I'll go back to questions for the people that are here. All right, that's it.